Hi everyone. In the year 1933, a scientist discovered something extraordinary in the space which surprised both astronomical science and human race.
The dark matter.
We call it dark matter.
Well, I would call it, if I had my druthers, I would call it transparent matter.
Dark matter not only doesn't interact with us, it doesn't interact with itself.
Oh yeah, that is an assumption, that's fair, but I do think they are particles.
In this video, we'll be exploring the unknown and invisible force of nature, the dark matter. So, what exactly is dark matter? How is dark matter different from normal matter? Why is it important to know its existence? And finally, what are its uses in the present world? Picture this. In the early 1930s, a Swiss astronomer named Fritz Zwicky is peering through his telescope at the Coma cluster. A group of galaxies far, far away, he notices something strange. The galaxies in these clusters are moving at such a high speeds that they should be flying apart, given the amount of visible matter we can see. But they are not. They are staying together. Isn't that weird? Zwicky did some calculation, lots of them, and realized that the visible matter like stars and gas just wasn't enough to account for the gravitational force holding these galaxies together. So he proposed something radical for his time. There must be some sort of unknown mass providing the extra gravitational pull. He called it Dunkelmaterie, which is German for dark matter. And just like that, the idea of dark matter was born. Now, you might be wondering, why didn't everyone believe him right away? Well, science is all about skepticism and proofs. At first, Zwicky's idea didn't gain much traction because it was hard to test. But over the decades, more and more evidence started piling up. Astronomers observed other galaxies and found similar oddities. Stars at the edge of the galaxies were moving faster than expected. This couldn't be explained by the visible matter alone. In the 1970s, astronomer Vera Rubin provided some of the most compelling evidence for dark matter. She studied the rotation curves of galaxies, basically how fast stars orbit around the center of their galaxies. According to the laws of physics, stars farther from the center should move more slowly, kind of like the outer planets in our solar system. But that's not what she found. Instead, she discovered that stars at the outer edge of the galaxies were moving as fast as those near the center. This was a game changer. Rubin's observation was crucial because it showed us that there must be a lot more mass than it is visible to us. Mass that doesn't emit any light. This unseen mass, which we call dark matter, provides the extra gravitational pull needed to explain the fast-moving outer stars. Rubin's work really cemented the concept of dark matter in the scientific community. So, in a way, you could say that dark matter was discovered through the combination of keen observation, brilliant deduction, and lots of scientific curiosities. It's amazing to think that how much of the universe is made up of something we can't even see. Imagine you're in a kitchen, everything you see around, the table, the chair, the food, that's normal matter. It's made up of atoms which are made up of protons, neutrons and electrons. This is the stuff we interact with every day and it makes up everything we can see and touch. Normal matter is what the stars, planets and even our bodies are made of. It emits, observes and reflects light, which is why we can see it. Scientists call this baryonic matter because it's made up of baryons, particles like protons and neutrons. Now, dark matter is a whole different story. Unlike normal matter, dark matter doesn't interact with light at all. It doesn't emit, observe or reflect light, which means we can't see it. It's invisible. But just because we can't see it, it doesn't mean it's not there. We know dark matter exists because of its gravitational effect on visible matter. Think of it this way. You're looking at a dance floor filled with the dancers who plays a role, the stars and the galaxies. You can see the dancers moving around, but there's something invisible tugging on them, guiding their movements. That invisible force is dark matter. It's like the ghost at the dance party. Apart from this, another piece of evidence comes from something called gravitational lensing. This is where light from distant objects gets bent around the massive objects like galaxies. The amount of bending tells us there's more mass there than we can see. Again, that's dark matter at work. So, to sum it up, normal matter is everything we can see and touch, which is made up of atoms and particles, which interacts with light. On the other hand, dark matter is completely invisible and interacts only through gravity. It makes up 27% of the universe, while normal matter only makes up about 5% and rest of it is filled with dark energy. So, till now we have understood what is dark matter, how we know its existence. You might be wondering, what's the point? Why should we even care about its existence and how it's gonna benefit us in the future? applications and uses of dark matter in the present and future world. Right now, dark matter doesn't have any direct application in our everyday life. We can't even see it, touch it, or use it in a traditional way. That doesn't mean it's not incredibly important. Understanding dark matter can help us unlock some of the biggest mysteries of the universe, and that knowledge could lead to groundbreaking advancements in science and technology. First off, dark matter plays a crucial role in the formation and structure of universe. By studying it, scientists can better understand how galaxies form and evolve. This knowledge can help us understand the past and future of our own galaxy, the Milky Way, and even predict cosmic events. Imagine being able to predict how galaxies will evolve billions of years from now. Also, dark matter research can help us refine our understanding of gravity and fundamental laws of physics. We have already had to revise our models of the universe because of what we have learned about dark matter. As we uncover more about its properties, we might discover new physics that could revolutionize our understanding of the universe. Who knows, it might even lead to new technologies we can't even imagine yet. Another exciting potential use of a dark matter research is in the particle physics. If we can identify and study the particles that make up dark matter, it could open up a whole new realm of particle physics. This could lead to advancements in high energy physics and potentially new forms of energy. Imagine discovering a new, clean energy source based on our understanding of dark matter. It's a long shot, but possibilities are exciting. Think about how the discovery of electricity changed the world. While dark matter research is still in its early stages, who's to say it won't lead to similarly revolutionary technologies? New materials, advanced computing, or even breakthroughs in space travel could all stem from understanding the dark matter. It's a thrilling time to be a part of a scientific community. The more we learn about dark matter, the more questions we get. And that's what makes the science so exciting. If you learned something valuable from this video, make sure to hit that like button, subscribe to our channel, and share it with your friends. Until next time, bye-bye.